Good day. Our topic is about sets. Any group or collection of objects is called sets. The objects that belong to the set are the elements or member of the set. To designate a set, it can be described using words or by use of roster method enclosed by the curly braces and separated by commas. For example, set of the days of the week. So we have here S. S is equivalent to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, enclosed in the curly braces and separated by commas. So that's how you describe a set. A set is well defined if it is possible to determine whether any given item is an element of the set. So take note of the term well defined. An example of that is the set of letters of the English alphabet is well defined because we all know the letters in the English alphabet. So that is what we call the well-defined set. Okay, let's determine whether each statement is true or false. Number one, 5.2 is an element, so therefore, this symbol here means is an element of right there. So 5.2 is an element of the set 1, 2, 3, 4, 5, and 6. So is 5.2 present on this set? No. Therefore, this item is considered false because 5.2 is not an element of the set of 1, 2, 3, 4, 5, and 6. Now, number 2, negative 101 is an element of integers. So is negative 101 considered an integer? Yes. So number 2 is true. Number 3, is 2.5 not element of W, where W represents whole numbers. So 2.5 is not an element of the whole numbers. So yes, that's true because 2.5 is not a whole number. Then we have 1/2 is not an element of integer. Yes, that is true. 1/2 is not an element of the I or the integers. An empty set, or what we call null set, is a set that contains no elements. So it can be represented by this symbol or an empty curly braces. So a set is finite if the number of elements in a set is a whole number. The cardinal number of a finite set is the number of elements in the set. So for example, we have number 1, j is equal to 2, 5. So what's the cardinality of number 1? So how many elements present or number 1? So that is 2. So how about number 2? There are 3, 4, 5, 6 to 31. And that is how many elements? So that is 31 minus 2. So that's 29. So there are 29 elements in the set S, which means that its cardinality is equivalent to 29. How about number 3? So it contains 0. It contains the number 0. So therefore, it is an element of 0. So single element means a single cardinality. How about this one? E is equivalent to null set. It means it contains no elements in the set, therefore its cardinality is equivalent to 0. Set A is equal to set B, denoted by this one. If and only if A and B have exactly the same elements. So for example, the first set is A, B, C, and the second set is say C, A, B. So they have exactly the same elements, though they are arranged in different ways, but they are still considered as equal sets because they have the same elements. set A is equivalent to set B, denoted by this one, if and only if A and B have the same number of elements. So take note of the term. Equivalent means they have the same number of elements. So for example, for this one, these sets are both equal and equivalent. So take note of the difference of equal. Equal means if they have the same elements, and equivalent means if they have the same number of elements. So those are the difference. Let's have some examples. State whether each of the following pairs of sets are equal, equivalent, or both, or neither. So for number one, we have 4, -2, 7. And then 3, 4, 7, 9. Since they don't have the same number of elements, they are not equivalent. And also, they are not equal. So, neither. So the set of all elements x such that x is an element of the set of whole numbers and x is less than or equal to 5. So what are the whole numbers equal or less than 5? We have 0, 1, 2, 3, 4, and 5. So therefore, we have, therefore, we have 6 elements in this set, and the second set has also 6 elements. Therefore, number 2, the sets are not equal, but they are equivalent. Okay, so they are equal. They are not equal, but they are equivalent. So that's for number 2. Now let's have some more exercises. Let's determine whether each of the sets is a well-defined set. Number 1, the set of good food. Now, can we distinguish what are the foods considered as good food? I don't think you can do that. Therefore, we'll consider number 1 as not a well-defined set. For number 2, the set of even integers. So we all know what are the integers considered as even. So we will consider this as well-defined set. Number 1 again is not well-defined set. The set of small countries. Okay? So this is considered as not well-defined set. So those are the difference between well-defined and not well-defined sets.